Hey, what is this? Equilibrium worksheet 1, worksheet 2, school program, worksheet 3. 7th page. Huh? Okay. This one, right? Ah, yes, please. You are asking some questions, right? Now, on that day, this boy sent a few questions. That one question, I solved that question, I think. And you are asking few more questions. Read the question. PCl5 gives rise to form PCl3 plus Cl2. 5 moles of PCl5 are placed in a 200-liter vessel which contains 2 moles of N2 and is maintained at 600 Kelvin. The equilibrium pressure is 2.46. The equilibrium constant Kp for the dissociation of PCl5 is, right? Now, final pressure they have given. So final pressure they have given. I want to know what is PCl5 initial pressure. This is the overall equilibrium, right? And I need to find Kp value. Kp value means, can I write concentration of PCl3 into concentration of Cl2 upon concentration of PCl5.
Kp.
No, that's why pressure. I am talking about pressures only. Okay. Pressure of PCl3 into pressure of Cl2 upon pressure of PCl5. Accepted? No. No. So I want to find partial pressures first. Now, initially, observe carefully what they have done. Do they make any changes in temperature? So temperature is constant. Is there any change in volume of container? So volume of container is also constant. If a pressure and a temperature are, sorry, if a volume and temperature are constant, means, can write number of moles is directly proportional to pressure, right? No. What they are saying? 2 moles of N2 is maintained. What is the meaning of this maintained? Means initially, if this container is having 2 moles of N2, finally also 2 moles of N2 must be present inside the container, because N2 is inert, which doesn't interfere in the reaction. Correct? Now, these 2 moles of N2 create some pressure. So in that final 2.46 atmosphere, I need to subtract that. Then only remaining is the pressure of remaining gases. Correct? Now tell me how to do it. Five moles of PCl5 are placed in a 200-liter vessel, which already contain 2 moles of N2 and is maintained at 600 Kelvin. So for this 2 moles, can I calculate what is the pressure? By using PV equal to nRT. So I am writing that. What is pressure due to nitrogen into volume is equal to number of moles into R value given into temperature, means pressure due to nitrogen is done. So 6 into 0.082, 6 2s are 12, 1, 48, 49, 4. So 0.492 atmosphere is the pressure due to nitrogen gas. Correct? Huh? Now, initially, how many moles of PCl5 is there? 5. That 5 moles also create some pressure or not now? Now, what is pressure due to 5 moles of PCl5? For 2 moles, this is the pressure means. For 5 moles, what is the pressure? Can you calculate or not? For nitrogen is 2 moles. 2 moles is creating a pressure of this much. Then 5 moles will create how much pressure?
5 moles of PCl5.
Yes, that's what I am calculating, only PCl5 initially. This is not there, this is not there. Understood, na? Now, 2 gives a pressure of 0.492. Then 5 gives X. So what is X value? 0.492 into 5 by 2. Correct, sir? Correct. Then 5 moles will give how much? Yes, 5 moles of PCl5 gives how much pressure? Yes. Volume and temperature are constant. Then number of moles is directly proportional to pressure. 2 moles have this much pressure, means 5 moles will have proportionality similar pressure. That's what I am doing. Correct or not? Reason? T, comma, V are constant. Correct, sir? Now, find this value. 0.73 atmosphere. So initially, what is pressure of PCl5? 0.73. Final pressure. Can I write 0.73 minus x? Then this is x. This is x. Sum of all this is equal to P equilibrium. Now, what is P equilibrium equal to? Yes, madam. Just now I am talking about her. 100 years. Yes. 0.73 plus x. This must be equal to correct. 2.46 minus 0.492. Correct. This is the final pressure, man. In this, nitrogen remained unreacted, so I need to subtract the nitrogen's pressure, na? Then remaining pressure is nothing but pressure of these three. Correct? So means what is x value equal to? 2.46 minus 0.73, 0.492. 2, 9, 10, 11, 12, 1, 12. So 1.222. Correct? So what is x equal to? 2.460 minus 1.222. 10 minus 2, 8. 5 minus 2, 3. 4 minus 2, 2. 1. So 1.238. Correct? Or something wrong? Wrong.
Sir, X value 1.23 coming, sir. That 5 moles of PCl5, that one 1.23 atm.
Here you are getting 1 point.
Yes, sir, 1.23.
You told 0.73. Common sense, man. It should be more than 1. Check. 2 0.2 sir, 4 sir, 6 sir. 0.246 into 5 means definitely it should be more than 1. 6 5s are 30. 3, 15 plus 3, sorry, 30, 23, 2, 12. So 1.23 atmosphere. See, man. So what is this value? 1.23 atmosphere. Good. Then what about this value? 1.23 minus x. This is x. So this value is 1.23 plus x equal to this value. So minus 1.293. Twelve, 1, 4, 5, 6, 7, 1.722. So 2.46 minus 1.722. What is that value?
0.738.
Point. He gave final answer. Huh? Now you got it, man. He has seen the solution or something. Right. So x value is 0.738. Means what is this value? 0.738. 0.738. And what about this value? 1.23 minus 0.738. Point? 1.230 minus 0.738. 10 minus 8, 2. 12 minus 3, 9.
0.492.
0.492. 0.492. Now tell me what is Kp? Kp equal to 0.738 into 0.738 divided by 0.492 over. Right? Check that value. 1.6 into 0.738. 0.738 divided by 0.492 into 1.5, that is 0.738, 1.107. That is 1107 into 10 power minus 3. Correct? Huh? So here answer must be 1107. Check the answer, sir. Correct? Over. Understood or not? Next question. Yeah, yes, sir. I brought a relation like this, man. First, by using PV equal to nRT, number of moles of N2 is 2, na? So for 2 moles, what is the pressure? I got this value. If 2 moles pressure is this much, then what is the pressure of 5 moles? Right? No, 5 moles of PCl5. Correct, na? Yes. Because temperature and volume are kept constant throughout the process. In PV equal to nRT, if V and T are constant, R is already constant, then what happens? Pressure and number of moles are directly proportional. Right? If number of moles increases, pressure also increases proportionally. That's what I have written. So P1 by P2 equal to N1 by N2. From here, can I write P1 by P2 equal to N1 by N2? That's what I have written. P1 by P2 equal to N1 by N2. Ma'am? Right, sir. Next question, sir. 76. 76. Read the question carefully. Variation of equilibrium constant with temperature is given below. They are changing temperature. Equilibrium constant also changing. Now we need to find delta H, delta G, delta H naught, delta G naught at T1, delta G naught at T2 respectively. Are close to. They are saying the values of. At T1 we need to find delta H value, delta G value. And at T2 we need to find only delta G value. Only 3 values we need to find. Right? Delta H value, delta G value at T1 temperature. And delta G value at T2 temperature. Only these 3. Right? What is Clausius-Clapeyron equation? Hey. Right? Now, by using this, they give K2, do they give K1? Do they give T1, T2? Then can you calculate delta H? Find delta H. So first one problem solved. If I substitute, and one more equation also, you know. Van Hoff equation. What is Van Hoff equation? Delta G equal to delta G naught plus RT ln Q. Correct? Huh? Delta G equal to delta G naught plus RT ln Q. At equilibrium, what is delta G value? At equilibrium, what happens to delta G value at equilibrium? Respond. 0. And what is Q? Becomes K equilibrium. At equilibrium, reaction coefficient Q value becomes K equilibrium. And delta G value will be 0 at equilibrium. Then if you substitute, what you will get? What? At equilibrium. At equilibrium, what is Q? Q is reaction coefficient. Reaction coefficient means concentration of product by reactant. At equilibrium, what is concentration of product by concentration of reactant can be called as K equilibrium. That's what I have written. Right? Now, at equilibrium, equilibrium means rate of forward, rate of backward, both become equal. Then what is the net change in energy? That's why delta G is 0. Delta G naught will not be 0 because delta G naught is at standard condition. At a standard condition, it may not be at equilibrium. But at this condition, when it reaches equilibrium, then delta G becomes 0. Clear? Understood? Now, substitute, then what you'll get? That implies delta G naught becomes equal to minus RT ln K equilibrium. Correct? Means what is delta G1 naught? I call this as delta G1 naught, this is delta G2 naught. What is delta G1 naught equal to? Minus RT1 ln K1. Delta G2 naught equal to minus RT2 ln K2. Now, can you calculate delta H here and delta G here, delta G here? Well, all the three values can you calculate now? Right? Solve and calculate. Done. Yes, sir. Folia, please. Don't use anything on me. Huh? 2 classes are there for me. Only for me. Hey, no. Done. Hey, how much? 28 point. Then answer is option 1. Hey, what is this K, man? Here 10, here it is 100. I am increasing temperature and I am increasing K equilibrium means what happens to delta G? Delta G is this value, na? This increase means this becomes more negative, right? So at T2, it should be more negative. So this value must be more negative than this. Correct? Hey, calculate and take, man. Don't rely on answers. They spoiled my shirt, man. Thinking that. Where is this Kalvi Internet thing?
Yeah.
Paravaya. Done. Sir. Sir. Sir, connect, sir. Yes, sir. Tomorrow is working day only. Holiday, yeah? I don't know. Okay. Oh, yes, yes. Working only. Working day only. Right, sir. Right, sir. Right, sir. Okay, okay. Oh, actually, one meeting happened today, but I am unable to attend that meeting. Maybe I need to find out. Then, okay. Okay, sir. Right, sir. Hey, calculated, not coming up. See? Not, sir. LG is not coming up. R value 8.314. Hello. சொல்லுங்க சார். இன்டர்நெட் ஆக்ட் 5G சிக்னல் போயாச்சு. వర్క్ ಆಗಲ್ಲ. ಅವರು yesterday night ಕಂಪ್ಲೀಟಾ ಇಂಟರ್ನೆಟ್ ಕಂಪ್ಲೀಟಾ ವರ್ಕ್ ಆಗಲ್ಲ. Late morning, today's morning it started working, but the data packet is very slow. Almost 6 Mbps. It was all lights are blinking. 5G light is not working. అది press பண்ணாட்டி. Then also it is not working. Because I tried yesterday night by searching in Google. I tried all these options. இப்போ நான் ஆபீஸ்ல இருக்கோம். Yesterday night I have also checked it. I think I will call madam. Someone, if anyone is visiting, I will inform madam. First delta H is correct or not? Have you checked it?
Yes.
What is 373 minus this is okay 75. Huh? Correct. Oh, okay. 2.303 into log 10. Log 10 is 1. So 2.303 into 8.314 into 373 into 298 divided by, you will get minus 75, minus of minus gone, equal to delta. Right? So you got delta H is equal to 28377.08 joule. Means 28.377 kilojoule. Correct? Next. Delta G equal to.
Sir, delta G1 value coming, sir, 5.71.
Delta G2 you are not getting.
No, sir. Delta G2 on to do.
Okay. 8.314 into T is 298 into ln 10 means 2.303. Correct? So 2.303 into 298 into 8.314. I got this value as minus 5705.8 joule. Means it is equal to minus 5.771 kilojoule. This is equal to 28.38. Better I can write based upon the given data. Now better I will write 38 kilojoule. Now delta G2 equal to, madam, నేను మీకు ఒక నెంబర్ షేర్ చేశాను యాక్ట్ ఫైబర్ నెట్ వాడిని, వాడు కాల్ చేశాడు, ఒకసారి వాడికి ఫోన్ చేసి ఉంటే వాడు ఇప్పుడు వచ్చి కరెక్ట్ బాగు చేస్తాడు. 8.314 into temperature is 373 into 2 into 2.303. I can write as 10 square. Means I will write 2 into 2.303. Correct? Done. So 8.314 into 373.
Sir, we will get
into
delta G1 double value, sir.
Not double value.
Sir, because only.
Temperature is
Oh,
also
sir.
gone, na? 373.
Okay.
So I am getting this value as 14283.7679. I will write as 77 joule. Means can I write this value as minus 14.29 kilojoule? I got the value. What? Now we have to do, man. You are engineers, na? Mathematicians, engineers. Next. Any other? So can I delete this? Okay, okay, let it be. Question number 60. 60. 60. You asked for chemical equilibrium, you are absent. Chemical equilibrium discussion over. Only lechatlier principle left. That is also single statement. With one statement, I will close it. Ionic, I told na single method. Total positive charge equal total negative charge over. Whatever condition you give, I will take one condition and I will solve everything. Physical chemistry that easy, man. Read this question. A plus 2B gives rise and form 2C plus D. If initial concentration of B was 1.5 times concentration of A, but the equilibrium concentrations of A and B were found to be equal. Easy one. Try, at least try this one. You try this. Understand the question and try to do. Done. Array, super. Try to understand one statement now. JEE preparation, most of the people will feel difficult. Right? And simply they will claim we are not able to understand, or our SAR is not able to explain me properly. First condition is you need to attend classes regularly. Right? So if I started a chapter and if you missed one lecture means total chapter is gone. Accepted or not? Right? So if a chapter got started, you need to attend all classes till the chapter ends. Then start solving questions. It will be very easy. Right? And in every chapter, hardly 2 to 3 important concepts will be there, which is part of the chapter. If you understand these concepts perfectly, from that concepts, you can generate the total chapter. Right? So you need to identify which is more crucial. Pick that, master it, chapter is over. Right? Here what we have done. A plus 2B gives rise and form 2C plus D. Initially what they said, sir? Initial concentration of B was 1.5 times of A. Can I assume concentration of A as 1? Then B will be 1.5. Your choice. Or if you consider it as A, then it will be 1.5A. Your choice. Whatever you want, you assume. If I assume 2, then it becomes 3. Your choice, man. Nothing wrong. Right? And what you assume 2 so that all fractions will be removed. What he has done is, sir, here it is 1.5 times. If I assume 2, automatically this becomes 3. So you will not get any fractions. Nothing wrong. Right? Now, when time t equal to equilibrium.
Sir, I'm
what
getting
they said?
third option, sir.
Third option, correct. Then can I write as 2 minus x? Then this becomes 3 minus 2x, because if 1 mole of A reacts, B will react to 2 moles. Then here it will be 2x. This will be x. What they said? equilibrium concentrations of A and B are found to be, means 2 minus x equal to 3 minus 2x. Bring that minus 2x to this side. What do you got? X equal to 1. If x equal to 1, then what is k equal to? 1 into 2 square, correct? Upon 1 into 1 square. What's that? Easy or not? Next. Number of moles gone. This one. Array, this one. Okay, let me write it. K equal to concentration of C square into concentration of D upon concentration of A into concentration of B square. Correct? Now tell me, X value is 1 means this value is 1. Then what is this value? 2. Then what is this value? 1. This value also 1. Substitute. Over. Correct? Next. That's all? Right. Now I am going to single statement. Okay, shall we? Listen. If I disturb an equilibrium, whatever I am trying to do to equilibrium try to nullify it. Right? If I am trying to increase, equilibrium tries to decrease. Whatever I try to do, equilibrium tries to nullify the disturbance I created. Clear? So I am writing that into a statement. When an equilibrium is disturbed, it adjusts, yes, madam. It adjusts in such a way to nullify the disturbance made. Over. If I disturb an equilibrium, then equilibrium will adjust in such a way, whatever the disturbance I created will be nullified. Right? Now your choice. Whatever the disturbance you want, you do it. Over. For example, N2 plus 3H2 gives rise and form 2NH3. And it is an exothermic reaction. This is the equilibrium reaction given. Right? Now I am trying to disturb it. You tell me what disturbance I need to create. You tell me, I will do it. You tell what, in what way I need to disturb it. Which one? Which concentration? You tell, whatever you tell, I will do. H2, right? Condition 1. Can I call it as increasing concentration of reactant? Are you told to increase H2, na? So can I call it as increasing the concentration of reactant? If I increase the concentration of reactant, what equilibrium has to do? If I try to increase concentration of reactant, it tries to decrease it. How concentration of H2 will be decreased? If reaction happens in forward or backward? If a reaction is moving in backward, what happens to H2 concentration? If reaction is moving in backward, what about the amount of H2? Amount of H2 increases. What I have done? If I increase what I told you, if I am increasing, equilibrium has to decrease. I am increasing H2 means equilibrium has to moving away that H2 should decrease. How H2 value will decrease? Over. Equilibrium shifts in forward direction. Over. Are you able to understand? So on increasing concentration of reactant, equilibrium adjusts in such a way to decrease concentration of reactant. Instead of saying equilibrium adjusts in such a way to decrease concentration of reactant, simply I will write equilibrium shifts in forward direction. Can I write it? Actually, in fact, what I have to write? I have to write this as equilibrium adjusts in such a way to decrease concentration of reactants. This I have to write. Correct? That is forward reaction is favorable. Right? Now, what happens to K equilibrium value? On increasing concentration of reactant, what happens to K equilibrium value?
It remains same, sir.
What are the factors affecting equilibrium constant? What I told you?
Temperatures.
We discussed yesterday. Huh? What are the factors affecting equilibrium constant? Catalyst has no effect. Mode of representation. Do I change the mode of representation? No. Then do I change stoichiometric coefficient? I added any two reactions or subtracted any two reactions? Do I change the pressure? Do I change the temperature? If I have not changed them, what happens to equilibrium constant? Is there any term like concentration term? Is there any factor of concentration? So what happens to K equilibrium? Remain same. Do I say rate of forward is increased or rate of forward is favored? So increasing is different, favored is different. Right? Listen. I will recommend your father to give you 500, please. Your father gave 500. So both are saying I favored you to get 500. It doesn't mean that you got 500, right? Rate is favored, but rate is not increased. Do I told rate is increased? I never said it. Forward is favorable than backward. That's all. It doesn't mean that rate of forward is increased. If rate of forward increases, what happens to concentration of products? If rate of forward got increased, what happens to concentration of reactant products? Increases. Then automatically rate of backward also increases. Na? Then again rate of forward backward becomes equal. Then it again reaches equilibrium. Then it remains constant again. Are you able to understand? Clear? So concentration of products increases. At the same time, backward speed also increases. Reactants also increases. In such a way, both ratios remain again same. Right? Okay. You may be confused because of it. So I will remove it. Right? Forward reaction is favorable. Can I write like this? Instead of writing rate, I am writing forward reaction is favorable. Can I write in that way? Hello, madam. Yes, madam. Good evening, madam. Yes, madam. Yes. Yes, madam. Madam, now I think they have removed this Vinod sir. Removed one foundation faculty there. If we want remove, then I think again faculty will be balanced. Understood? What's up? Now give another condition. Pressure, okay. Whatever you say. So, what you are doing? Increasing or decreasing? Right. Increasing pressure. While we discussed about characteristics of equilibrium, have you discussed anything like it should be done in closed vessel?
Yes, sir.
Right. So, I need to do that in closed vessel. In closed vessel, how can I increase pressure? You are saying pressure to increase. Don't say again temperature. Temperature is affecting equilibrium. Pressure also affect equilibrium. Don't make both to influence at the same time.
Sir, you close the sir.
Compress. This is the room, man. This room is closed or not? Right? If I compress this room, what happens to pressure inside? Over. Your condition satisfied or not? Correct? Over. So, I am increasing pressure means, you know, PV equal to nRT. Can I write P equal to N by V RT? Right? P is constant. R is constant. Then to increase P, what should happen to N by V? So N by V should increase. Correct? So N by V should increase. Correct? Means I am increasing N by V means what equilibrium has to do. So equilibrium should adjust in such a way to decrease N by V. Now tell me how N by V will be decreased. If N decreases, or in N by V, if N decreases, what happens? N by V decreases. Correct? So I am trying to increase N by V. Then equilibrium adjusts in such a way and decreases N. If it decreases N, automatically N by V decreases. Done. Problem solved. Correct? No confusion now. I will explain. I will explain. Right? That is on increasing P, so under that P I am writing N by V increased. Correct? Then equilibrium shifts in such a way to decrease N. Equilibrium shifts in such a way to decrease N. Hello? Hello? Means N by V. Hello? Oh, yes, sir. Yes, sir. Please. Yes, sir. Yes, sir. Yes, sir. Okay, okay, sir. Yes, sir. Actually, we have one FTS program happening, sir, for repeater students. So those who are interested to utilize that now, we asked those students to come give the test and followed by paper discussion, and then let them go to their own biology preparation. So that's why I'm asking them to come to branch to give any test. Better either code A or code B. Let them have that choice. Okay. Yeah, yes, sir. Oh, yes, sir. Please, because already till now 3 papers are done. Let her give one paper, any one of that paper. Tomorrow also there is one FTS 2B paper is going on. Yes, sir. Yes, sir. Please. Then I will inform our team also to call all such interested students. So you may get call again. Huh? Okay, sir. Right. Yes, sir. Yes, sir. Yes, sir. Yes, sir. Please, sir. Right, sir. Welcome, sir. Welcome, sir. Correct now? Any questions, sir? Now see this, sir. I am taking this reaction as it is. What is delta N of this reaction, sir? What is delta N means? Number of moles of products in gaseous phase minus number of moles of reactants in gaseous phase. How many products in gaseous phase? How many reactants in gaseous phase? Then what is the value? Okay, very good. No, leave that. Now come back. If I increase pressure, what should decrease? Which should decrease? Number of moles should decrease. Now, if a reaction moves in forward or backward, in which case number of moles will decrease? Either if it moves in forward or in backward, in which case number of moles decreases. Why? 4 became, at a reactant side there are 4 moles, product side 2 moles. If it moves in forward, 4 moles are becoming 2 moles now. So number of moles decrease. Means what is favorable? Correct? Now I am writing one more reaction, sir. Now, what is delta N, sir? 0. Then, which is favorable, forward or backward? Why? Why? You say something. Forward favorable or backward favorable?
Sir, here there's no effect of applying pressures.
Why? Whether it moves in forward or backward, you cannot
Moles
change number
is
of
same.
moles. When you are unable to change number of moles, equilibrium has no effect. So there is no effect on equilibrium. Now I am taking one more reaction. Yes. When delta N is 0. When delta N is 0, pressure change cannot affect the equilibrium. Correct? Now see this one. In this case, what is delta N, sir? Can I write this as delta N less than 0 here? Can I write this as delta N greater than 0? Correct? Now tell me. How number of moles will decrease now? Forward or backward? Over. So backward reaction favorable. Now tell your condition. Temperature? Then whatever you say, I will do, man. Right? Done. Shall I go for the next one? Right? What do you want? Decrease in temperature. Huh? Right. I am writing decrease in temperature. We can discuss this effect in 2 ways. One by using Clapeyron equation, another without using any equation. Which you want? Without, huh? Without means single step. Do both, huh? Okay. Then also single step only. Now see this, man. N2 plus 3H2 gives rise and form
2NH3. Is it exothermic reaction or not? So delta H of reaction is less than 0. Instead of writing that, can I write minus Q? That is delta H is equal to minus Q. Why, man? Why I have written that way? Minus Q or plus Q? See, how much amount of Q lost in the reaction? Q kilojoules per mole is the energy released. Correct? I am writing Q on product side means energy got released. Energy got released means exothermic. If it is exothermic, what should be delta H? Minus Q. Correct? So this is exothermic reaction. Now, what you are doing, sir? What we are doing here? What you are doing? Decreasing. I am decreasing temperature means I am cooling it. I am cooling it means what I am doing to this Q? Removing. Correct? If I remove Q, what equilibrium has to do? It has to produce Q. To produce Q, what it has to do? Forward or backward? Forward. So equilibrium shifts in forward direction. Understood? Right? So this is exothermic reaction. Therefore, on decreasing temperature, forward reaction is favorable. Next. Classius-Clapeyron equation. Okay, I am doing this by using Classius-Clapeyron equation. By using Classius-Clapeyron equation. What is Classius-Clapeyron equation, sir? ln K equilibrium 2 upon, instead of writing K equilibrium 2, can I write Kp2 upon Kp1 is equal to minus delta H naught upon R into 1 upon T2 minus 1 upon T1. Correct, sir? Correct? Now, here also single step. If it is exothermic reaction, what happens to delta H? If it is exothermic. Exothermic means delta H of reaction will be less than 0, negative. Then what happens to this minus of minus? So this term will be positive. Correct? Correct or not? No. Whether I am increasing temperature or decreasing temperature. If I decrease temperature, T2 value will be less than T1. Correct? So denominator T2 value is less means what about 1 upon T2 value? What is 1 upon T2 value? More. The T2 is decreasing means I am decreasing this. Means I am increasing this. Then this total value becomes Again, again I am repeating. What I am doing? I am decreasing temperature. Decreasing temperature means T2 is less than T1. Bring that to this side, the T1 to this side. So 1 upon T1 is less than 1 upon T2. Correct or not? Right? Then what is 1 upon T2 minus 1 upon T1? Then what about the total value on product side? If a total value is positive means, what about ln y by x is positive means? What is the relation between y and x? Y upon x must be greater than 1.
Yes, sir.
Log
Greater.
ln 1 must be equal to 0. I should get greater than 0 means ln y by x value should be greater than 1. Means y should be means Kp2 must be greater than Kp1. In which case? In case of exothermic reactions on decreasing temperature. Correct, sir? Correct. K equilibrium value is increasing. Correct. K equilibrium value is increasing means can I write K forward is increasing? And K equilibrium means K forward by K backward. Correct. So K equilibrium value is increasing means can I say K forward is increasing or K backward is decreasing? Correct or not? Correct. That is K forward is increasing or K backward is decreasing. Means indirectly forward reaction is favorable. Now tell again condition. Your choice. What condition you need? Whatever you want, you tell, man. Any condition you keep and check. If I am disturbing, it adjusts in such a way that disturbance should be nullified. If you increase reactant, it will decrease it. If I add products, it will remove products. If I remove reactants, if I am removing reactants, what happens to equilibrium? It has to produce reactants, means backward. Correct? Understood or not? Any questions in it? Now I am giving one condition. Will you give it the answer? Condition, sir. Addition of inert gas. We already solved one problem over it. Just now we solved. PCl5 is undergoing reaction to reach equilibrium in presence of N2, which is inert. Same condition. I am adding N2 gas. Now tell me what happens to equilibrium? I don't want that. I want whether it is forward favorable or backward favorable, what is favorable. I want that condition. Okay, I am taking all the three conditions. Tell the condition. Hey, don't blindly say same. What number of moles decreases? What you are saying, man? Listen. Listen. I am adding inert gas, right? When I'm adding something to the equilibrium, what happens to volume of the vessel? if I keep the pressure constant. I am adding inert gas now. Right? If I am adding inert gas and I don't want to change pressure, then what should happen to volume of the well? Means volume increases yet constant P. Correct, sir? Correct. So I don't want to increase pressure. So I am saying pressure is constant. If I am keeping pressure as constant, obviously volume increases. Then what happens to volume in all cases? In all cases, volume increases or not? Response, sir. Better I am writing here. Any questions? Right? Then what happens to N by V, sir? Hey, V increased means what happens to N by V? Decreases. Then what equilibrium has to do? Increases, it has to increase N by V. To increase N by V, it has to increase N. So how I will increase N here? Over. So here backward favorable. Here forward favorable. Here over. Okay. If pressure is not constant, means volume should be constant. Pressure should increase and volume should be constant. Right? So I am adding inert gas by keeping volume constant. If volume is constant, then what is N by V? Constant. Or you are saying volume is kept constant. If you keep volume as constant means what happens to N by V? N by V you kept constant. Don't say, sir, I am adding number of moles of inert gas. What is that? Inert gas. Inert gas means it doesn't have any influence on the reaction. If it doesn't have any influence in the reaction, what is the use of number of moles you have added? No use. Means what happened to N by V? Constant only. Right? If N by V is constant means I am not changing N by V. If I don't change N by V, equilibrium also doesn't change N by V. Means so what? Result. Pressure is increasing means what should happen to N by V? Should increase. But you are saying volume is constant. Number of moles of number of moles of what you are increasing? Not increasing. Number of moles of inert material you are increasing, not number of moles of either reactant or product or anything that involved in equilibrium. That's what I'm saying now. Because you have not influenced the N, either N or either V. Means you have not influenced N by V. If you have not influenced N by V, you have not influenced the pressure of the components involved in the equilibrium. You are changing pressure of the total atmosphere, but not pressure of the components. If pressure of components is not influenced, means partial pressure of reactant, partial pressure of products are not influenced, means Kp, not influenced, means nothing happened to equilibrium. That's why I wrote no effect, no effect, no effect.
For N by V to change, we should affect either N.
Either you have to change N or you have to change V. Then P changes. If a P changes, then Kp changes. Then equilibrium got disturbed.
Pressure also not disturbed.
Where? Second case. Pressure of total cylinder or total vessel got changed, but not pressure of reactants and products. We call it as a partial pressure. Partial pressure of reactants and products has not been. That's why it's way. Understood? Clear, sir? Any other condition? So we are done with chemical equilibrium total chapter. Right? Means half of ionic equilibrium chapter also. Based upon this idea only, instead of molecules, we will use ions. If I use ions, ionic equilibrium. If I use molecules, chemical equilibrium. Right? Any conditions?
Whatever conditions are there for
Your choice, man. Whatever you want, I will give.
future.
You want some? Can I give one condition? Right. Boiling of egg. I took one egg, man. I kept that egg in a boiling water, which is maintained at constant temperature. Right? Temperature is kept constant, and I kept boiled egg inside it. What? The amount of heat flowing into the egg, the amount of heat coming out of egg should remain constant. At that point, what happens to the egg? Egg boils. I think okay, forget about boiling. Think in a different way. I have taken a 10-liter vessel. In the 10-liter vessel, which is completely empty, vacuum, nothing is there, right? In that, I have taken 2 liters of water, which is converted to ice, 2 liters of water, which is not converted into ice, but in liquid state. I kept both in this. Now what? What is temperature of ice there? 0. What is temperature of water? That is also 0. So both are kept at 0. Ice at 0. Water is also 0. 2 liter, 2 liter. Everything is kept in a sealed container. What happens? Water becomes, then ice becomes. What man? You are not even getting it. Okay, I am even simplifying it. This room, in this room, I kept a bucket full of water in this room, and I switched off AC. Right? I kept one bucket full of water in this room. What happens? Okay, water started evaporating. Till what extent it will keep on evaporating? Till it reaches equilibrium. Very good. So water is trying to convert into water vapor. At the same time, water vapor also trying to convert into water. Now it reached equilibrium. Correct? When it reached equilibrium, what happens to pressure of water vapor inside this room? Remain constant. Because it reached equilibrium. If reached equilibrium means amount of water converted into vapor and amount of vapor converted into water both became equal. Means amount of vapor in air got saturated. Right? Air got saturated with water vapor. So what is the partial pressure of water vapor in air now? Constant. Correct? We call that as P naught. What do we call it as? P naught. Right? Now, this is called vapor pressure. P naught. Saturated air's vapor pressure. Right? Because of some reason, right? Suddenly, vapor pressure of moisture in air becomes greater than the value. What? Air should be, for example, if I keep a bucket of water here, amount of vapor in air should reach 1 atmosphere. Assume P naught of moisture in air is 1 atmosphere. Because of some external factor, this room air's water vapor became greater than 1 atmosphere. Means what happened? Equilibrium got disturbed. Then what should happen? It shifted. Means what should happen? Vapor should convert into water. That is rainfall. That's how rainfall is happening.
Here also converted.
Correct or not? That's how fog is forming. During winter, why fog is forming? Because of this reason.
Sir, why it becomes to converted to liquid, sir?
You only told rate of backward becomes favorable than rate of forward. Equilibrium should shift in backward direction.
Sir.
Correct?
And delta n is less than 0.
Here delta n is greater than 0. Because liquid gas. Correct?
Ah, yes, sir.
Liquid and gas.
Yes.
H2O liquid converting to H2O gas means delta n is greater than 0.
0.
Correct or not? So if because of some external reason, if a pressure of moisture in air suddenly becomes greater than P naught, then rainfall happens. We call it as condensation. What we call it as a not precipitation. What we call it as converting vapor to liquid. What we call it as precipitation only. Precipitation is there. Right? If it decreases,
Sir, sir.
uh,
Evaporation.
evaporation increases. Means what happens to sweat on our body will evaporate or will not evaporate at that condition. If suddenly pressure of moisture in air became less than P naught, then what happens to sweat on my body? Converts into evaporate. If a sweat on my body gets evaporated, it takes heat from my body. If it is taking heat from my body, what I will feel? I am losing body temperature. At the same time, I am losing moisture, means I will get dehydrated. At the same time, I will feel very cold. Understood or not? Correct? If P became greater than P naught of moisture, then pressure of moisture in air became greater than P naught of moisture. Then condensation is favorable. Then what happens to sweat on my body? Will not evaporate. If sweat on my body is not evaporating, what happens to my body? My body tries to heat it because it wants to lose. To lose water, it keep on increasing the temperature of my body. Then my body's temperature rises, my heartbeat rises, and water is not going out. Then I will lose my energy. I feel suffocated. Breathlessness. Correct? That's why before rainfall, your body feels it as suffocating. So today rainfall will happen. Reason? Moisture from my body is not evaporating. If moisture from my body is not evaporating, means air is already more than saturated than what it should be. If it already got more than saturated, it tries to lose it. When it is trying to lose it, it has to go for rainfall. Understood? Now then, at Chennai and at Bangalore, why people feel comfortable at Bangalore than at Chennai? Yes, so what? Because of sea temperature should decrease. What we generally feel. And because of sea temperature should decrease, but what happens to moisture content in air? Increases. Then what happens to sweat from my body? It will not evaporate. If it doesn't evaporate, I will feel suffocated. I will get irritated. Correct? At Bangalore, it is the middle part of the country, at the center of the country. Then what happens to moisture content in air? Low. Then sweat from your body gets evaporated quickly because air is very dry. So you need to hydrate more. Correct? So body is losing heat more. So what you will feel? Cold. Correct? So that's why Bangalore is called air conditioned city. What air condition is doing? Air condition is keep on removing moisture from air and it is dripping that moisture as water outside. Then what happens to moisture inside this room? Then what happens to sweat from your body? Goes out. So you will always feel over. Is also equilibrium or not? That's all. What, sir? Anything else? Right. Online, is it clear? Right, sir. I will end the session. Right. If possible, I will take the next session also, if required.
Yes, sir.
I will ask next. Actually, which class for you? Kalyan, sir. Doubt clarification. Okay. I will end the session, sir. I will try to rejoin. Depends upon my other conditions. Okay. Right, sir. I will end it.
Thank you.
Yes.